back from lunch. I hope everybody enjoyed it. So we're going to kick off this afternoon with David Gonzalez and Alex Knoll. I hope I pronounced that correctly. Close enough, deadly.
Yeah.
And we're going to be speaking about DevSecOps with K8's staying safe at the speed of light. So,
thank you very much. So we really didn't want to use another buzzword. So
we are missing blockchain.
True. So it's the last time we'll mention it, DevSecOps with K8s or Kubernetes. What that really is about is putting security at every step of the software development lifecycle. And in this talk, we're kind of going to talk to you about how you integrate those things into your pipelines. So my name is Alex. I'll just leave out the last name. I'm doing secure DevOps at NEARFORM, but that's just the title. I'm helping clients and companies build automation pipelines and help them with security in those pipelines and also after. David, you wanna?
Yeah, I am the same. I'm David Gonzalez. I'm now 7 years in Ireland, and some of you might remember me from the last year. I'm doing the exact same that Alex. We are just, it's a buzzword as well, and we say that no more buzzword, but here we go. We are doing DevSecOps, so we started on DevOps, and we thought that it wasn't enough, so we just specialize in security and making sure that the software going to production and staying in production is safe. And Alex?
Yeah, so typically security, especially in larger organizations, is something of an afterthought. So there's a development, then you build it, and then at some point you want to deploy it. And then there's like InfoSec, right? It's going to stand in your way of you and your beautiful app and production. And that's typically a bottleneck, you know, and it's going to slow you down. And then by the time they come back with the results from, let's say, the pen test or something else, you've already moved on to a different feature or whatever. And you have to get back into what you delivered, let's say, 2, 3, 4 weeks, or maybe a month ago, or 2 months. So when you're practicing CI and CD, everything is automated. So why not just automate the security into that as well? And there's very good tools to do that, and also very good reason, because as with a bug that you find in production is very expensive to fix because you have to go all the way back at the beginning. It's the same way with security flaws. So if you're finding a security flaw, or even worse, you have been hacked and you want to fix that in the next release or as soon as possible, it's very expensive to fix that. So what we've come up with, I can use this thing, here we go, is a 3-step process. So you have prevention. So this is as far left as you can pull it, so all the way to the developer laptop, or even before that at design time. And what you do in that phase is you kind of try to make the attack surface as small as possible. So things like removing dependencies that you're not using, at least running scanning on your code to make sure that it's at least the best you can do. Kind of preventing vulnerable things for even getting to the next stage. So the second part, after you've done all your prevention, which you can probably get about 80% of all the things that could hurt you. So there's about 20% left. And if you wanted to do that all with prevention, you have to do a lot of research and dot all the I's and make sure that there's nothing left to exploit. So when you get into detection, you're kind of changing over to letting the product or your application run the way it is with the best effort prevention, and you're going to monitor behavior. So as an example, an Nginx server or a web server should be communicating on, let's say, SSL port 443 or 80, but if there's something going out of that container or activity on that container in port 22, for instance, well, we all know that it's probably bad, right? So you want to have detection that gives you an alert, and then also mitigate or do an intervention as soon as you detect this. Because typically in a containerized environment, you will have 10, 20, maybe 30 of these Nginx pods running in your Kubernetes cluster. So which one is the one that generate this 22 activity? So you have automatic intervention that takes the alert and automatically kills that pod that was communicating on the SSH port, so that the hacker that apparently got in there only has milliseconds to do anything harmful. And all of this requires visibility, because when these things are happening automatically, they may even happen without you being notified. You just get your Monday morning email saying, okay, we have had 3 or 4 attempts of a breach, but we still need to fix this thing for the long run, right? So every time they maybe get 1 or 2 seconds to get into your environment. So everything needs to feed up into a visibility layer that gives you actionable results to mitigate this problem. So maybe it was a dependency that you pulled in, maybe it was some bad code that was deployed. You want to know and then feed that back into the pipeline. And like I said, feed it back into the pipeline. It's like with anything, you just rinse and repeat. You get feedback and you keep improving your system as you go along. Some facts around vulnerabilities and security. I was quite amazed actually when I was researching for this talk that 39 seconds, every 39 seconds there's an attack. These are numbers from the site on the bottom there. That means I've been talking now maybe 3 minutes. How many attacks is that? And how many of you have something in production that potentially may be attacked while we're sitting here? 64% of the companies have experienced web-based attacks, so that is roughly maybe this part of the room is being attacked or has been attacked. Could be people on the other side as well. The cost of attacks is going up, and the reason for that is that data is ever more integrated with other data. Systems are integrated, so where maybe traditionally you'd be able to get a few user records, now they're tied to other stuff which is much more valuable, so one attack can lead to another. And by that measure, things are going to get very, very costly. And there are days that I don't have 150 million in my pocket, so it's probably good to, try to prevent these things. The next one is, kind of amazing to me. The ridiculously large number of stolen records every day since 2013. So I thought this was all the records that were stolen since 2013, but it's the daily average. So that's 44 records every second. And this kind of comes back to the automatic intervention, because even if you are a really fast typer and you can get to this node and this container in, let's say, 2 minutes, you may have already lost, 44, so maybe 250 records by the time you get to it. So you need something automated, just like you need Kubernetes to automatically keep your stuff alive if it crashes, or help you with availability. Same thing you need around security. There are things you can do. These are some of the vendors that could help you. They're not even all of them, and all of them cover a certain part of the spectrum when it comes to security. Some of them actually encapsulate everything, but that means you'd have to buy into the entire ecosystem, and it's not really easy to get out of. So what we've done is we've kind of come up with a reference pipeline architecture that kind of helps you to, it's like a blueprint, I guess, to put the right things in place, and they can be open source or commercial. These are mostly commercial, to really help you do the prevention, detection, and automatic intervention. And David's going to take you through the first step.
Yeah, so when we were working on these slides, I just came up with this image, which is very powerful. So information is power, and yet you see an iceberg. So as you can see, an iceberg only shows around 15% of the surface, which is problematic, which the captain of the Titanic knew that because it didn't end up well. So in your IT systems, it's about the same. In your IT systems, you need to know what's going on to take the best decision, the possible decision. And that is okay when you are monitoring production from the log point of view, and it's okay when you are monitoring production from there is an error happening, or this customer is spending 20 seconds in this page when it should be just clicking a button, what's going on. So we have tools for that, but when it comes down to security, we don't really have any tool to do that. So what the problem is that security is not aware of the full development lifecycle. So what happens in big companies, or even in small companies, is you have developers working for 2 weeks in a sprint, and then Thursday, the second week, goes into InfoSec. InfoSec does an assessment and comes back to you saying, oh, by the way, this thing that you have based all your features this sprint, it's broken, so you cannot release that. Then what happens is the people in the driving seat wants to release no matter what, so you end up working 12 hours overnight from Thursday to Friday to get something which is going to be at the very least buggy and deployed to production on Friday. So yes, it's secure, but you now might have broken other features because you were rushing the QA for a critical vulnerability. So another point here is that CI/CD, continuous integration, continuous delivery, does not pan very well with this approach. So you cannot just assume that they're going to deploy 3 or 4 times every day, and then security needs to review that. So the only way that we came up with solution to this was DevOps. But the problem with DevOps is that the DevOps engineers do not know about security. So hence, we just came up with DEVSECOPS, which is DevOps engineers on steroids, which it's probably getting like Power Rangers way too deep, but you know, it's what it is. So like, the thing is, there is a new world out there, which is Kubernetes, which is Docker. It's developers deploying to production 20 times a day without anyone else being aware. And developers rolling back from production without anyone being aware. And I work right now in companies like that, where you empower your developers, but then you don't get the sensible part of what is this developer doing, or what is the effect into my customer base of what this developer is doing right now in production. And from the security, is the same. So if we release some code, which apparently is not malicious, but it turns out to be an exploit, how can we know that? It's really hard nowadays to know that. So this last phrase, I repeat it quite a lot. I need to come up with something better because it's not very catchy, but it makes a lot of sense. When you have many, many possibilities, what happens is that investing in them is not cost effective. There is a rule which probably some of you do not know but have experience, is that 80% of the work is going to take 20% of your time. But the leftover 20% of your work, it's going to take 80% of your leftover time. So perfect is the enemy of done, and security is not an exception. So whenever you are working with security, once you reach the level on prevention or detection, of 80% of your work done, you need to move to another activity to maximize your value. Small startups cannot spend millions in buying tools from providers that Alex just shown a few slides ago, and hoping for the best. You just need to be cost effective on how you are doing your security. And I think now Alex is going to talk to us about, well, actually, not yet. I'm talking a bit more. So whenever I go into an engagement with a customer, the first thing I do is, how do you capture your information? How many here are developers? Hands up. Oh, wow, that's a lot. Okay, so, and all these developers, has anyone ever released code which has a vulnerability with a CVE assigned? No one? You? One? 1 out of around 60. That's a very low percentage. And now the question is, the other 59 developers, are you 100% sure that your code is safe? Anyone with confidence? Hands up? No? You? Out. I can guarantee you that it's not safe. 100%. So the same way that I can guarantee you that your code is not safe, I can guarantee that my code is not safe, because my dependencies is your code, and your code is flawed the same as mine. So how do we know if our dependencies have vulnerabilities? Like Alex and myself, we are both part of the Node.js security working group. So whenever someone reports a vulnerability in an NPM package, we are part of the team that reviews that vulnerability and assigns or claims a CVE for that vulnerability. And I can tell you, there are so many obvious things that you wouldn't even think as a vulnerability, but allows you to list passwords in your system or list files and similar. Then, on the same way, when you are going to Docker, how can you guarantee that your base image hasn't been compromised? Like, I don't know if you read the news, you probably do because you are sitting on a computer the full day. So, last week, 17 images from the Docker Hub were taken down because they were backdoor, and no one knew about that for months. And backdoor means someone gives you access to production. Okay, so that's pretty scary, and no one ever here has vetted a Docker image, and I can guarantee that as well. No one ever has just gone into the official Node.js image or Java and said, okay, what are the problems on this image? Because it's official. Like, it's the same way when you download Debian, or is Debian still a thing? I think so, yeah. Sorry. Or Ubuntu, or something similar, whatever is up now. You don't question the people who is building it because you know they are good, but with Docker happens the same. And we will show you something scary later on. And again, like some companies might have the luxury of installing the image or your artifact in a public repository, like GitHub or, I don't know, Docker Hub or similar. But some other companies are on the stake for not releasing code or not leaking code because if a military company or a military organization leaks code, problems, like really problems. I mean, you cannot just go and show the code of your missiles or your base or your satellites in the internet because someone might get, really, really pushy on that. Mm-hmm. And also, how can you guarantee that no one has tampered your images? And all of this goes down to application security and making sure that your application is sound. And Alex is going to tell more about that.
So, thanks, David. Yeah, application security. I mean, we saw that the majority here is developer or in some form working on applications. When you're talking about security inside the application, the thing that we find most in the conversations we have with companies is it comes down to awareness and education. So I don't know how many of you had security training as a developer. Well, quite a few. That's good. That's good. But it was not the same amount of hands that we saw before for the developers. So that's kind of gives you an idea of where the biggest win is probably to be made. And there are actually tools to help you with that. So you could do static code analysis that will give you feedback in the CI/CD pipeline or even on your own development laptop. You could have static code analysis give you feedback right away when you're changing files or committing. I would not use that to block the build because it's not always real security issue. There's a lot of false positive when it comes to static code analysis, but it's definitely a tool that you can help to educate yourself and a team if you manage one. An interesting detail around application security is that when developers are asked about security flaws detected and how many of those flaws are then not fixed, they come up with a number of 40%. So 40% of the security flaws that have been identified in code knowingly go to production because other things have priority. I'll come back to that in the next slide after this one. Who here has heard of the Owasp top 10? That's good. That makes me very happy.
Well, particularly because it means you came by our booth and got the amazing leaflet.
That could be. So, I mean, it's a well-known list of the 10 most important web application security items that you should be paying attention to. Number one is still injection. So, make sure you validate anything and everything that comes into your system from wherever you get it, even if it's another microservice or something that you think you might be able to trust. I'm not going to go through all of them. You can, we have these flyers, the folders at the booth in the lobby, so you can pick one up and keep it on your desk as a reminder or something. The interesting thing here is, to me or to us, new on the list since last year is logging and monitoring. And that kind of comes back to what I said before. You know, you need visibility, and the monitoring part will help you with the things that you didn't find while you were preventing all these vulnerabilities. And it's good that Owasp agrees with that with us. So we mentioned Owasp. As David said before, there is no such thing as vulnerability-free software. I guess you know, you can do your best in making your code as secure as possible. There's a few other things you can do to help prevent security flaws as you push your code into a remote system. So that code is one of those, removing dependencies that you're not using, and then obviously scanning those things. And also, interestingly, there was a breach a while ago in a authentication package or a backdoor, and there's actually it would be very interesting or advisable to take critical parts that would give access to the entire system, like an authentication system, and not use a library from a third party, and just write the critical parts of that yourself as your team, because that guarantees that at least that part of your app is fully in your control. Up-to-date dependencies, we mentioned it before. Training and education for developers is very important, but like we kind of identified before, sometimes other things are more important. So we do let these security flaws kind of slip through the mazes of the net, because, you know, maybe delivering features or something else is more important. So that's why we kind of advocate that security should be a KPI for development teams, and even should be part of the design phase. So before anybody hits a keyboard and starts typing, we should already have thought about security. And that's actually one of the things research is also showing, that many times when a vulnerability is discovered, and you ask developers, well, what could you have done to fix this or to not have this hit the next phase? It's most of the time is design time. So think about these things a little bit more to the left of the spectrum, so moving it before development. If you then want to package your application to run in Docker and Kubernetes, I think you have some insights on how to do that properly.
Yes. Okay, so here people works with Docker, right? Like pretty much everybody knows what Docker is. Everybody has run a Docker container. So what can you do in Docker for the security to be at the level we want? That was the question Alex and myself asked a few months ago. And we came with, well, it's not our diagram, it's from the internet, like pretty much everything else nowadays. And it's the structure of a Docker image. In this case, it's Ubuntu 15.04, which it's a bit old, but you know, still it's widely used in Docker. So when you build a Docker image, what you do is you build layers and pack them in a zip. And basically a Docker image is a zip file composed with more zip files which are mapped one-to-one to layers. So in this case, your image is composed by 4 layers, which are the ones in blue, green, I don't know, whatever color this is. And they are one on top of the other. So you can see the SHA commit, exact same way as GitHub. Here, well, you cannot see because it's too small, but you can figure it out. And then, you know, you have 4 layers, and this is your Docker image. Then, when you run your container, what happens is the Docker engine creates a new layer on top of this image, which is the only writable layer of the full stack. And what happens is your container is running. So if you do changes in your container or in production, they are not going to be stored in the image. They are going to be stored in the layer on top of that. So then when you stop your Docker container, what happens is your image comes back to the, well, it goes nowhere because it has never left, but comes back to the normal state, which is, it means that the image is immutable. So immutable is a word that you should be keeping in your mind if you are working with computers, because it's the new Windows 98 or new big thing in computing. Like when you are in AWS, Google Cloud Platform, Azure, you don't mutate your infrastructure. You just create a new server and dispatch the old one. with Docker is the same, and it was built with that in mind. So if you rerun your image, what happens is your changes from the container are not in the image. They are in another image, which is composed by another layer more on top, which was the writable layer on the previous container. So this causes questions, and the question is, what can we do to ensure or guarantee that this artifact here, the image, is vulnerability free? So if you go to the next slide, you can see a URL here. We built a vulnerability scanner. Okay, this one is only for Node.js, but what it does is it crawls the full Node modules packages, listing all the packages that our application is using, and we are matching that against the few databases. One of them is the Node.js Security Working Group database, which is public. Everybody can use that. NIST, MVD, all the public databases that we could find, which are all channeled via OSS index. And it's the proof that making secure the Docker images is not as hard as it sounds, but then it comes back to this. Okay, I have another question. Who will deploy this into production? It is a Docker image which has 1,041 vulnerabilities. Of those, 189 are high severity. Hands up? Nobody? Okay, who is running Docker in production at the moment? Okay, a few hands. So you have deployed this, because this is the official image for Java or Node.js. Well, actually, it's Debian at the moment in the repository. The good part is, don't be scared. Majority of them are false positives, and it's because the way that Debian manages the data is not ideal for the scanners, but still creates a lot of noise. So if tomorrow there is a huge vulnerability going into Debian, you won't notice, because it's going to be 189, 190, and you probably won't even see that. Okay? So it causes a lot of noise, and it's scary. And this blew my mind the first time I saw it. It's like the official image from Debian saying, hey, I am official, I am Debian. 1,041 vulnerabilities. Makes no sense. So in order to prevent that, we came up with, I would say, a reference architecture plus a set of tools that my colleague Alex is going to tell more about.
Yeah, I realize, I think we have about 10 minutes more? 15? Because we have prepared a little demo, and I kind of don't want to take too much time away from that. So, I mean, we've talked about all the parts that you see in this diagram. On the top, you have prevention, detection, and intervention, which are kind of the new items we're bringing forward. But build, deploy, and run is something that everybody does inside their deployment pipelines, right? There's nothing new there. So, what happens is you combine your code in the build step with a base image from Docker Hub, hopefully not the one that David showed before. And actually what you probably want to do is check all the base images and kind of certify them or tag them in some way that you have verified that these are the ones that are not running as root, for instance, and are not installing any weird packages and don't have have all the right security aspects, really. Once you combine the code and the base image, you get an application image. This is the image that is then frozen and tested. We're testing it before it goes to the next phase. Again, with an application vulnerability scanner. So you're running, after this thing has been built inside the container, you're going to run the, let's say, a SNCC scanner, for instance, to make sure that your Node.js packages are not vulnerable. But then you're also going to scan the actual container again, because while you were executing Docker build, you might have installed some things that you really shouldn't. And then that image, actually, I'm missing the laser thing, but the image is then frozen and should be traveling all the way as is to your production environment, if it makes that far, So in the second phase, where you're doing the deployment, you typically deploy this to a testing environment, QA. Maybe you have some other steps in your process, and you'll be testing it for performance, load testing. Maybe there's a manual testing step, or some people looking at UI, for instance. But this is also the place where you want to use something like Zap Proxy to do automated pen testing. So what ZapProxy does is basically implementing tests for the Owasp top 10, and it will give you a very nice report that you can then feed back into your visibility that has to sit across all 3 phases to give you a report on where you stand. And you could even accept certain things because they're not a valid attack vector for your specific application. But you definitely want to know where you stand. And this also gives you like an indication, what your level of security is according to where you want it to get to, for instance. And then the run part is where we deploy this thing to Kubernetes. So you have a cluster, be it on Azure, or if you are lucky, you already have the AKS or the EKS in Amazon. You can run it on-premise or wherever. But whatever you want to do is make sure that on the nodes that are running your containers, you are scanning those like you're doing with the containers for vulnerabilities at the OS level. And if your provider doesn't provide it for you, then you should do that yourself. And also, very important, you should be checking that also with an automated scan that runs repeatedly, not just once every quarter, for instance, that your API server or any other orchestrator endpoint is not open to the internet. I think Tesla maybe rings a bell. So that is kind of where prevention ends and where monitoring starts, because on those nodes, you want to be installing a behavioral monitoring tool, and we have successfully worked with open source tools like Falco or Capsule 8, but there are also many vendors that we may have seen on the slide before. And what they do is they just look at the behavior of, well, any process running on that node, and if something is running inside a Docker container, it's just running on that same kernel that is running on the host. And it's monitoring for behavior that you find suspicious. And whenever something suspicious happens, you flag that. There's an alert going into the automatic intervention system. So that's like the action ellipse at the end. And that will automatically take action if it's at the level where you think it's harmful enough to be killed immediately. Like the example I gave before with Nginx, there's no question. You want to kill that immediately. And having said that, that's kind of the last part is what we really want to demonstrate. So I hope we can make this live demo work.
Yeah. If it doesn't work, don't worry, don't panic. Yes, the door is there. Keep running. Nobody's going to get harmed. So we have built a small system which basically uses the MetaWeather API to get you back the latitude and longitude of a city. So for example, Alex, can you get me back where Dublin is?
Dublin, let's see. I think we have that. Yes.
Okay, so you can see latitude, longitude, and that it's what a company might use for locating their customers. So I want to know in a 3D model of the Earth where my customers are. But just before the talk, and this is what terrifies me, I just came up with a new module, a new version of the module that we use for that. So Alex, can you go to GitHub and show me the, I have created a pull request here. So MetaWeather now is version 2.0.0. So I'd say we can release that for demonstrating.
I mean, what could go wrong, right?
Can you show the changes?
Upgrade. Yes, I can show the changes.
Yeah.
I think
it's in files. No, if you go down files change.
Yeah, but then we get the package.json. So
yeah,
so it's just going from 1 to 2. And I guess we are okay with that. So I'm going to merge this pull request.
Conversation.
A bit awkward with this screen. No. So I say merge. That's fine. Okay. So I'm going to pull that latest change into my local repository. And then what I did is I made a little CI/CD script, so I'm not running a full CI/CD pipeline. And that's kind of this script that just increments the version number, tags the Docker container, pushes it to Docker Hub, and then updates the Kubernetes manifest and pushes it to the cluster. And actually, I mean, the cluster is kind of made visible down here with the pods. So these are the 3 pods that we have running at the moment. And maybe I should have started that before I started talking.
It's fine.
Well, it goes pretty fast, I think. Internet is
Okay, so meanwhile this is deploying, can you just show me the vulnerability analysis of this image?
Yes, I think I may put that here.
Yeah.
So maybe we should go back to the actual, where did that go? Here we go. So the Docker file for the image is this. I mean, there's nothing, strange in here, right? This is probably something we've all deployed many times. Or no?
We've done, yeah. Come on, we've done.
Well, I scanned this image. It's a tag number 1, but it really comes down to what is in the base image that's behind here. And you can actually see that this is the Anchor scanner I'm using. It's, you can use it for free. It's not, we're not affiliated or anything. But just to show you that, there's like 8 or 9 high vulnerabilities, and they're actually recommending to not deploy this to production, because these are, filtering out the, what was it? How many vulnerabilities?
1048 or something, 1041.
So they filtered out the 1030, and the rest are real vulnerabilities.
Yeah, and many of them are in packages that you don't use in a Docker container, so problems.
Yeah. Okay, so we just catch the last update here of the Kubernetes cluster.
Okay, so then should we test it with New York, for example?
Yeah, let's have a go.
We tried Cork. Unfortunately, it's not showing up.
It's
Sorry.
not on the map. New York. So, very good.
Okay, perfect. So then, now, can we have a look to the
Yes.
behavioral monitoring, what's happening in the background?
Yeah,
so
because
you've seen or
of course
changed.
we installed something in our node, like I said before. And here this is showing the output of that behavioral monitor. And what it's showing here is that I made a rule that this particular thing is not supposed to communicate to the outside world on port 80 because it's running on 3001. So,
Yeah. So what's going on here? I can explain you very easily. Okay, the guy who built the meta weather module in NPM, it was me on the last week. So this module has like 3 downloads. Mainly it's us. And I was talking to a friend in a bar that I'm working for this cool company, blah, 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 blah. Then someone approached to me saying, I'm going to pay you 7,000 euros or 10,000 euros or an obscene amount of money, which didn't happen, to buy this package of you, because I know the company NEARFORM is using it, so I want to target them. So you know what that means? That means that the person who owns this NPM module has direct access to my production. So what happened here is that the person, me, who bought this package has introduced in the code, and we can see that in index.
just if you.
Yeah, so it has introduced a post request into a third-party service, which you can see there highlighted. And this is all by a change of a version on a library. It's crazy, like just one number, and it's actually a good practice to keep your dependencies up to date. It's playing with your production. So I could easily have destroyed half work here. And what we are doing is sending where our customers are based to a third-party application. We use request catcher because we didn't have time to build something more sophisticated. So we use some sort of request catcher in the background. So what can we do to prevent that, Alex?
Yeah, so I'm going to go into the server or the Kubernetes cluster that we're running on Azure here, by the way.
Yeah.
And I've installed the behavioral monitor in there, so that's running at the moment.
Yeah.
But I've also created something that I call the auto killer.
And this is something we built off ourselves. Like it's like 8 lines of bash code, which is going to allow us to stop containers which are having security problems from the vulnerability point of view. So it can be quite problematic if you don't have something like that, because I mean, what we have done here is we have the. Do you need to go to the?
Yeah, I'm getting there.
Yeah, okay. We have here our pods running. We are using Watch, same style as Kelsey Hightower. So we see all the things running here. And you're going to see now how, as soon as we hit the URL which hits the container with a problem, the auto killer is going to start doing things.
Yeah, so I just refresh this one, and then you'll see the auto killer is identified based on the behavioral monitor that container with ID blah 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 is doing bad stuff. And it's just taking that ID and running a Docker kill.
You can see the H here.
Yeah, and then this is where you can really take advantage of what Kubernetes does for you. So where it helps you with keeping things alive and restarting them, it also helps you in security because you can just kill. And I mean, I could do this a lot of times and it'll keep going, but we never went offline, right? So we have Kubernetes taking care of our availability while we are making sure that we're still secure.
Yeah, and if it's a hacker who is compromising our infrastructure, he only have like milliseconds to act before being kicked out.
Yeah, so at 44 records a second, he may have had 2, 3.
If any.
So, so with that, where are we? We go back. We say thank you and ask for any questions.
Because you have questions, right?
Can you show us AutoKiller Bash?
Yes. Oh, it's ridiculously simple.
It's 8 lines. He wrote it. He's lucky I'm married.
I thought it was in here somewhere.
Autokiller. Yeah.
Oh, here we go. Okay. Maybe
Yeah,
I should
now
just
you-
look at it while I'm typing. So it's just getting the output, the standard out of the Falco process in this case, and then JQing it until you get the ID. I mean, this is proof of concept at best.
It's 8 lines of glory. Like these 8 lines is protecting you from having a problem, serious problem in production.
Yeah. Any other questions?
Yeah, can you explain a little bit where you defined where external access on the network was not permitted, right? So do you actually have to define that, or do you assume external network access is disallowed by default?
Well, I mean, there's both ways you can implement it. If you're using something like Istio, you can really confine like the service mesh that is on top of your software-defined network. But you can approach it from the other side where you say, okay, these syscalls are not allowed with these parameters, and then you can kind of lock down that way. The way Falco does it is more of a blacklist type of thing, so it gets kind of tedious to do everything except for these 2 things that we do allow. So you have lists and macros and stuff to help you with it. But I think Capsulate uses like a whitelist approach where it's a bit easier to maintain.
Yeah, Falco is more high level. You define the rules in YAML file and you can do many things. And then what Capsulate does is it gives you a stream of events, and then you have your state machine, which the events are going to be like this, and this allow, this, and this allow. So. Yeah. More questions?
More questions?
Sorry for that.
I think we forgot to say that we are hiring.
Yeah, like everyone does.
Okay. Thank you, David and Alex. It was a great talk. And we're back at 5 to 2, which is not too far away at all, with Randy Shoup. Or 5 to 3 even, because 5 to 2 is gone. Cheers.